Welcome back to my series of videos where I'm modelling how we can tackle some of these really challenging calculations that appear in the quantitative chemistry topic at GCSE. In this video, we're going to be looking at how we can use the molar ratio and the calculations involved to work out which is the correct balance symbol equation for a reaction. So let's have a read of this question. Copper oxide can be produced by two different reactions. So we've got reaction 1 and we've got reaction 2, and you can see there's a slightly different ratio of copper to oxygen, and there's a slightly different formula there for copper oxide. 58 grams of copper was reacted with exactly 6.4 grams of oxygen. Justify using calculations which reaction was used to produce copper oxide. As always, we need to start off by bugging our question. I'm just going to move the camera down slightly. So we've got 50.8 grams of copper. Okay, now it's in grams already, so we don't need to worry about doing any conversions for that because that's in our standard unit that we use for chemistry. Of copper, we need to underline our chemicals that we're using. Was reacted with exactly 6.4 grams. Again, that's in the unit that we're used to using. We don't need to worry about doing any conversions. Of oxygen. Justify, that's our command word, so we need to give a reason for our answer. Using calculations, so we need to show our calculations, which reaction was used to produce copper oxide. And we've been given the relative atomic mass of copper and oxygen that we'll need to use for this reaction. So this calculation is quite similar to the limiting reactant calculation that we looked at in the last video. And we will need to use our mass equals moles times MR calculation in order to solve this. And we will need to look at the molar ratio and work out which is the correct reaction. Okay, so to start off with, we need to work out the moles of our two chemicals. So we need to work out the moles of copper. So let's think about how we can use this equation to work out the moles of copper. Well, we want the moles by itself, so that means we need to divide both sides by the MR. So that tells us that mass divided by the MR equals the moles. So what's the mass of copper? Well, the mass of copper is given for us 50.8 grams. Divided by the MR, well, it's just copper by itself, so we just need to use the atomic mass of copper, which is given for us in the question, which is 63.5. We then plug that into our calculator, 50.8 divided by 63.5. That tells us we've got 0.8 moles of copper. So the next thing we need to do is work out the moles of oxygen. And remember, the formula for oxygen is O2, so we're going to need to take that into account in our calculations. So we do the mass of oxygen, which is 6.4, divided by the MR of oxygen, but we're going to need to work out the MR because it's not just one oxygen atom, it's two oxygen atoms, so it'll be 16 plus 16, which equals 32. So let's put that into our calculator again. 6.4 divided by 32. That gives us 0.2 moles. So once we've got our number of moles, we need to work out what the ratio is between the copper and the oxygen and use that to work out which equation is correct. Okay, so we need to scale this ratio up to a whole number ratio. Okay, now the simplest way to do this is to divide your smallest number by itself, and that will give you 1 mole, and then divide your bigger number by your smaller number. Okay, so we want the ratio of copper to oxygen. Let's move down slightly. So we do the smaller number divided by itself, 0.2 divided by 0.2, and that will give us 1 mole. Okay, and you can see we've got 1 mole in both of our equations up at the top. And then if we do 0.8 moles of copper divided by 0.2, 0.8 divided by 0.2, just putting that in the calculator, that tells us we've got 4 moles of copper. And then we need to justify, so we need a sentence explaining this down at the bottom. This ratio is the same as reaction. Let's just check which reaction it is. Well, it's 4:1 ratio in reaction 2. So this ratio is the same as reaction 2. Okay, so it's important to have that sentence at the end there to explain your working. So let's just have a look at where you would pick up the 5 marks. You would get 1 mark for calculating the moles of copper. You would get 1 mark for calculating the MR of oxygen, so 16 plus 16. You would get 1 mark for calculating the moles of oxygen. You would get 1 mark for scaling this up to a whole number ratio, so 4:1 moles. And your final mark is your sentence to compare that ratio to the ratio that's in reaction 2, so your sentence at the end. So there we have it. That is how you use the mass equals moles times MR equation and the molar ratio in your balance symbol equation to decide which is the correct balance symbol equation for a given reaction. Hope you found this video useful. Tune in next time where we'll be looking at the concentration calculations that you need to be able to do for solutions. Bye for now.